I'm Dr. Alicia Cummings, and in this video, we're going to discuss the nature of the phonological representations of children with speech sound disorders. So it's presently unknown what underlying mechanisms might account for the problems children with speech sound disorders encounter when producing speech. One explanation is that our children with speech sound disorders or phonological disorders cannot produce specific speech sounds correctly because they have poorly specified phonological representations, which result from inaccurate speech sound perception. So speech sound production errors might stem from imprecise speech perception, which then results in inaccurate and or less detailed phonological representations. So what are phonological representations? They are the building blocks of verbal communication. They're formed by decoding the speech signal, which in part requires the extraction and the sequencing of the features of the phonemes in the auditory signal. So to accurately perceive and produce speech, a speaker must successfully access the phonological representations of each phoneme or sound. And those phonemes are combinations of distinctive features, with each phoneme being distinguished from another phoneme by at least one feature. And these features are stored in the phonological representations of each phoneme. So to explain, it's been proposed that adults only store contrastive or marked features in their phonological representations, while default features are not stored because they're assumed to be predictable by phonological rule. So this results in phonemes that have more or less specified phonological representations. Little, though, is known about the specification of children's phonological representations. Bernhardt proposed that underspecified features are established first in a child's representation, with those specified features gradually appearing throughout development. And not surprisingly, typically developing children are hypothesized to have more specified phonological representations than children with speech sound disorders or phonological disorders. Phonological theory suggests that, for example, B and D or B and D are different due to the markedness of the place of articulation of the phoneme, with D being a coronal sound produced with your tongue tip behind your top teeth, which is assumed to be an unmarked feature that is the default place of articulation, while B is that labial sound, which is considered to be a marked feature that must be stored in the phonological representation. And so the question is whether this is actually the case, and if so, how and or when does a phonological feature become a default or less specified feature in a stored phonological representation? So we did a study looking at children and adults' responses to buzz and does, or bas and das, and to see if we could identify a timeline of which this happens. So here are event-related potential or ERP responses, which are essentially time-locked EEG or brain responses, neural responses to specific stimuli. So in this case, are bas and das. And the MMN or the PMR peaks are characterizing a change detection in the auditory input, meaning that the subject, the participant, identified a difference in the sound that was being produced. So the change is being characterized by feature differences of the B and the D, rather. Is it a labial sound or is it a coronal sound? And based on the data that we found, we proposed a developmental trajectory for phonological underspecification, with our typically developing children and our children with speech sound disorders or phonological disorders functioning at different points on this continuum. And we have 3 separate stages here based on our data, from disordered children to typically developing children to adults, that shows a change over time in how features were specified in phonological representations. So our first stage of phonological representation occurs when our child is just developing and defining the representation of that underspecified phoneme. So in this case, the D. Since underspecified phonemes are considered to be less complex than specified phonemes, it is proposed that the features of that underspecified phoneme are developed prior to those of the specified phoneme. So in this stage, the features of the specified phoneme are not yet defined in that representation. So in the case here of b and d, the d is defined and temporarily specified within the d representation, while that labial place of articulation is not yet part of that b phonological representation. Our model goes on to propose that in our second stage of phonological underspecification, the child is developing and defining the phonological representation of the more specified phoneme. So here, the features of the more specified phoneme b are now phonologically defined in that representation, while the features of the underspecified phoneme, the d, continue to be temporarily specified. So here in this case, our buzz and does are now both assigned to their respective phonemes. And then in our final stage here that we observed in our adults, that occurs when only the features of our specified phoneme are defined in the phonological representation, with the underspecified phoneme features no longer being specified because they're considered to be that default. So in this case, the default place of articulation. So this stage assumes that over time, children learn which phoneme features are phonologically defined in a representation and which ones are default features. So in this stage, the coronal is assumed to be that default place of articulation. And so that means only the labial place of articulation is specified in the b representation, while the d does not have a specified place of articulation.